Ethanoic acid is a monoprotic acid. What is meant by monoprotic? It only has one proton to donate. Which ions does ethanoic acid give rise to in aqueous solution? Give their chemical formulae. So the first thing is that the minute we go into water, an acid will form the H3O plus ion, and what's left over is CH3COO minus. In other words, ethanoic acid was 2 carbons, C, and then O, so CH3COOH, and the H comes off and joins that ion. A solution of ethanoic acid of concentration 1 mole per cubic decimeter conducts electricity, but not as effectively as a solution of hydrochloric acid of the same concentration. Give a brief explanation. So ethanoic acid is a weak acid. That means that it makes few ions. Therefore, poor conductor. Whilst hydrochloric acid is strong, and obviously everything else is the opposite way around. So it makes many ions in solution and therefore is a good conductor. A standard solution of sodium hydroxide is made up by dissolving 2.5 grams of sodium hydroxide in enough water to make up that volume. Define a standard solution. It is a solution of known concentration. Sodium hydroxide is a strong base. Differentiate between a strong base and a concentrated base. A strong base means it forms many ions, form in solution, whilst concentrated means that many moles have been added to the water. Calculate the concentration of sodium hydroxide solution prepared. So if I'm going to calculate the concentration, the first thing that I need to do is I need to say number of moles, mass over molar mass. I've been given a mass, 2,5. The molar mass of sodium hydroxide is 40, 23 plus 16 plus 1, and then that is equal to 0,0625 moles. Now if I want the concentration, number of moles divided by volume, it is equal to 0,0625 divided by volume of 0,5. I need to change that 500 centimeters cubed into decimeters cubed, and I get 0,125 moles per cubic decimeter. 20 centimeters cubed of this solution, so we've just made it, of sodium hydroxide is titrated against ethanoic acid. The balanced equation is given. The volume of the acid required for the titration is also given. Calculate the concentration of the acid. So the first thing I can do is I can say, what were the number of moles, concentration, times by volume, and I am going to be using 20 centimeters cubed, and they told me in the previous part that the concentration, well, we calculated in the previous part, it was 0,125. 20 centimeters cubed is 0,02 decimeters cubed, and that is 0,0025 moles. The mole ratio is a 1:1 mole ratio, which is quite nice because then I can just take that number of moles straight in. Concentration is equal to number of moles divided by volume, 0,0025. The volume is of the base is 0,0245, and I land up with 0,102 moles per cubic decimeter. Would the end point of this titration be acidic or basic? Briefly explain your choice. Well, this is a strong base and this is a weak acid, so we're going to land up with a basic endpoint since there are more OH minus ions in solution than H3O plus ions in solution. Name a suitable indicator for this. You are expected to have a vague clue of 3 indicators at least, so phenolphthalein, is a good endpoint at around 8 or 9 indicator. If sodium ethanoate were to be dissolved in water, what would the approximate pH of the solution be? So now we're talking about the salt that we have formed, which was sodium ethanoate, and what we are going to see is that it would have to be approximately 8, probably around 8 to 9 would be the pH of that solution. When 0,1 moles per cubic decimeter of ethanoic acid is dissolved in water, the following equilibrium gets established. Those are the ions. I think we asked about those ions earlier, so actually it's been given to you. The pH of the solution was measured to be 3. Define the acid in terms of a Bronsted-Lowry model. An acid is defined as a proton donor. Identify the acid-base conjugate pairs. So this is a proton donor, so it's acid 1. Once it's donated it becomes base 1. This is a proton acceptor, so it's base 2. Once it has accepted that proton, it becomes acid 2. So the acid-base pairs are given by those two links. What is meant by autoprotolysis of water? It is when it decomposes into the ions H3O plus and OH minus spontaneously. Write a chemical equation to show that. You've got 2 waters which are in the liquid phase. You land up with OH minus and H3O plus, and both of them are in the aqueous phase. Differentiate between oxidation and reduction. Pure definitions. Oxidation is loss of electrons, and reduction is gain of electrons. Identify the oxidizing agent and reducing agent in the reaction below by using oxidation numbers. On its own 0, on its own 0, aluminium is in group 3 plus 3, chlorine is in group 7 minus 1. If you were to add those up, it becomes plus 3 minus 1 minus 1 minus 1, and it ends up being overall neutral. Let's see what has happened. Aluminium has gone from 0 to being plus 3, so that is oxidation. And the chlorine has gone from 0 to minus 1, that is reduction. What type of bonding takes place in aluminium chloride? Briefly explain your answer. It is a metal and a non-metal, so it is going to be an ionic bond due to the exchange of electrons, the transfer of electrons between a metal and a non-metal.